Hi everybody, this video is for the Unit 1 guided notes. This is just part one of many guided notes that we'll do for Unit 1. Very first thing we're doing here is reviewing some Algebra 1 stuff for solving one variable equations and inequalities. Not a whole lot of notes, but a ton of examples because this is review. So let's take a look here. So recall to solve linear equations, we want to use inverse operations, and I really should have added in here, remember our ultimate goal. When we solve these, our ultimate goal is to isolate the variable. So I surely should have added that under here. Isolate the variable. So our ultimate goal is to isolate the variable. To do that, we're going to use inverse operations. And I'm going to do two of these examples with you, and then I'll kind of just pause. I'll tell you to pause the video and try the other two on your own, and then check your answers with mine. So in example 1, I have an equation, right? There's an equal sign, so I want to solve for this variable x. Before I can use inverse operations in this one, though, I have to combine my like terms. So I have like terms here with the 3x and the minus 4x. So I'm just going to go ahead and combine those two like terms. So positive 3x minus 4x is negative x. Everything else I'm going to keep the same. So this equation now becomes 1 minus x equals 4. And now I'm ready to isolate this variable using inverse operations. So I need to cancel this 1. I need to move this 1 to the other side. So to do that, I'm going to subtract 1 because subtracting 1 cancels a positive 1. And if I do it to the left side, I have to do it to the right side. So now I'm left with negative x equals 3. And the last step, a bunch of ways you could think of this. You can divide by negative 1. That's usually how I think of it, right? This is technically a negative 1 times x, so you divide both sides by negative 1. Dividing cancels multiplication, and you end up getting x equals negative 3. Other ways you could have done that, you could have multiplied by negative 1. You could have just made the other side negative, just common sense. Negative x equals 3. That means positive x is negative 3. Any case, you get x equals negative 3. And if you wanted to check your answer, you could plug that negative 3 back in for those two x's and see that it makes the equation true. I'm going to do example 3 next and then have you pause the video. Example 3, again, I want to isolate this variable k, but there's some work I need to do. I can't combine like terms yet. I do have to start by distributing this 6. So this is going to become, and I'm going to take the plus with it. Plus 6 or positive 6 times k is positive 6k. And then positive 6 times positive 1 is plus 6. Everything else in the equation is going to stay the same. So that negative 90 stays the same. The 6k in front stays the same. And now I got to combine like terms like I did in the last one. So if I combine like terms, that's 6k plus 6k. That's 12k. And everything else stays the same. So this is still negative 90 on this side equals 12k, and that plus 6 at the end is still plus 6. And now I'm ready to use inverse operations to solve for k. So to cancel a plus 6, I use the inverse, which is minus 6. But I have to do it to both sides of the equal sign. So I get negative 96 equals 12k. And then to cancel that 12 in front of the 96, I'm going to have to divide because dividing cancels multiplication. Again, inverse operation, so you do the opposite operation here. So if I divide both sides by 12, you should get negative 96 divided by 12, I believe, is negative 8. Equal to k. And again, you could plug that in to check it if you wanted to. Go ahead, pause the video right now and try examples 2 and 4 on your own. I'm going to do them as well and just kind of reveal the answer here. When you press play, you'll see both answers. So here are your answers to 2 and 4 in the examples, the guided notes. You should have gotten a equals negative 8 for number 2, and for number 4, you should have gotten r equals 3. So the first section of the homework tonight is based off solving equations similar to these 4. All right, on to solving linear inequalities. They work the exact same as solving equations, unless you multiply or divide both sides by a negative. If that happens, so if you multiply or divide both sides by a negative, what happens is you must switch the inequality. Oops, not switch, switch the inequality. Meaning, if it was less than, you're going to switch it to greater than. If it was greater than, you switch it to less than. And let's see if I can get at least one of these. I'm only going to do 2 of these examples for you because they are so much the same as solving equations. So let me see if in one of these I can make it work where we switch. I'm going to go ahead and do example 5 and 7. And then again, you can try 6 and 8 if you want, but they work the same. Again, just be careful if you multiply or divide both sides by a negative, you have to switch the inequality symbol. And I'll show you when I'm back in class tomorrow. I'll show you why, because you might not know why. And I think it's important you know why. But for now, just kind of believe me. I will show you when I have a little bit more time in class tomorrow why this happens. So if I look at this first example in 5, it works the same as the ones we just did above. I'm going to distribute the -3 first. That gives me -21 plus 15n. Everything else about this inequality stays the same. I still want to isolate the variable. It doesn't matter which side. So by the way, you don't have to put it on a certain side. Some of you may prefer the left, but it doesn't matter. So I'm going to isolate that n, so I'm going to have to add 21 to both sides. And here I get 105 on this side is greater than 15n. And again, still working like we just did with equations. Now if I divide both sides by 15, oops. So 15 cancels 15, and if I divide 105 by 15, and keep in mind again, the inequality is not flipping here. 15 is a positive. So when I divide by positive 15, nothing changes about that inequality. 15 is a positive. This blue number is positive. So 105 divided by 15 is just 7. That inequality stays the exact same way it looked. And this one's done. So n is less than 7. You could write it either way. That's the same thing as saying n is less than 7. 7 greater than n. I think I can fudge this next example to work where I flip the inequality. There are ways around it. So let me do this one real quick, and then you can try the other 2 if you'd like on your own. So again, I start out by distributing. So I get -24a minus 9. And let me go ahead and get all my a's on one side. So if I want to get my a's over here on the left, let me subtract 4a. And subtract 4a from the -24a. I'm going to add this 9 to get all my numbers on the other side. And let's see where I'm at. So now I'm at -28a is less than, this is kind of a poor example, less than 0. Again, I'll show you why tomorrow, why this inequality is going to flip. But when I divide by -28, anytime this number in the bottom is a negative, anytime you divide by a negative, like I'm doing here, this inequality is going to flip the other way. So it was less than, it's going to flip to greater than. Okay, and I'll try to highlight that real quick so you can kind of see why that happened. It started out as less than, but here in the end it changed to greater than because of this dividing by -28. And there's ways around it. You could have moved all the a's to the right side and you never would have had to worry about flipping the inequality. Go ahead, try examples 6 and 8. Pause the video, try them. When you press play, I'm just going to have the answers there. But check the inequality to make sure your inequality is facing the right direction. So here are your answers you should have gotten for 6 and 8. I just put the answers there. If for some reason you didn't get the right work, you can ask me when I come back tomorrow or shoot me an email. Or try it again, see if you get the right answer. But be careful, make sure you check your inequalities are facing the right direction before or while you're checking your answers. Let's look at some applications of equations and inequalities. So I give these 5 steps. They're my 5 recommended steps to solving a word problem. We're going to start by reading the problem. So let me go ahead and do this example. So Jim has $50 to spend at the fair. If it costs $5 for admission and $2.50 per ride, how many rides can Jim ride at the fair? Write and solve an equation for this situation. So I read the problem, and let's define the variables. The variables come in the question. So my variable here is how many rides. So I don't know, let's call our variable R. R is the number of rides. Now I go back and I reread the problem, step 3, and I translate into math and use the defined variable. So where is R going to fit in my problem? So Jim has $50 to spend. That's like saying he has $50 total to spend. It's going to cost him $5 for admission. So from that, his total cost, or what's going to cost him at the fair, is going to be $5 plus, right, and means plus, $2.50 per ride. Per ride means times the number of rides he goes on. So here's my equation, 50 equals 5 plus 2.5R. And you're going to solve that just like we did in the previous slide. To save time, because I only have 15 minutes per video, so go ahead and read through what I would do. I'd subtract 5 from both sides. That gives me 45. And then I'm going to divide by 2.5 on each side. And for R, that means if I divide by 2.5, I'm going to get R equals, I believe it's 18 if you divide that. Try the next one on your own. It's about Jill baking cookies. Again, I only have 15 minutes. So pause the video, pause it right now, try it, and then when you press play, I'm going to go ahead and put the answer up here, and you could at least check your answer. So your answer should have been 78 cookies. You don't have to, this equation kind of is irrelevant here. Common sense could have told you how many more cookies she needed. But if you wrote equation, solve an equation, your work would have looked like this. I'm going to go ahead and conclude that video after Jill's cookie example. I'm going to make a second video for the rest of the notes because this may be new for some of you. I want to make sure I have plenty of time, and right now in this recording I'm down to about 2.5 minutes. So I'm going to make a second video for compound linear inequalities.